So the first part of this chapter was everything logs. Now the second part of this chapter is going to be everything triangles, okay? So we are going to review what we've already learned about triangles and then extend it even further. So do me a favor, pause the video, and I need you to copy down what we already know. Or you can listen along as you're copying it down. Let me remind you, if all you need to find are the sides, then you can do the Pythagorean theorem. A squared plus B squared equals C squared. Or let me point out that the long side is your C squared. Okay, it's the one not touching that. And this is a right angle. It's got to be a right triangle or you cannot do the Pythagorean theorem. And then I look over here. If I want to find my sides and my angles, I can use sine, cosine, tan. But what has to be true? It has to be a right triangle. Okay? We've learned a lot about right triangles. We've also learned that if we have the hypotenuse, it's sine or cosine. So we can use those. If we don't have the hypotenuse, then it's automatically going to be tan. So what I want you to do is we're going to go through each one and decide, hey, could we find the other sides and how could we do it? What could we use? All right? So let's look here. We have three sides. Could we find the three angles? What do you guys think? No, we can't. We can't because it's not a right triangle. So we can't do anything. Oh, it's not a right triangle. Let me try that. Not a right triangle. So we can't find anything else. I don't know the rest. Now let's look here. We have all these angles. Can we find the sides? No, it is not a right triangle. So we've learned if you're given three sides, I can't do squat. If I've given three angles, I can't do squat because it doesn't matter. It's not a right triangle. Now let's look here. This time they're saying, okay, well, fine. If I have two sides and an angle, can I do it? So let's look over here. Could I find the length of this third side? Well, I sure can. I could find the length of this by doing a squared plus b squared equals c squared. And I could go, if this is my a squared plus 4 squared equals 5 squared. And some of you go, Ms. Rifkin, I remember this. Well, good, because you're supposed to. Some of you go, thank you for reminding me. You're welcome. Subtract 16. Square root, square root. So now I know this side is 3. Okay? Now I got the sides. Could I get the angles? And I'm going to do this in pink. Okay. And can I get the angles? Yes. I can get the angles by using sine, cosine, or tan. Now remind me, how many degrees are in a triangle? In a triangle, there are 180 degrees. Let me move this over so you can see that. So don't forget that. So that means that if this is 90 degrees, that means this one plus this one is also 90 degrees. So really, you only have to find one of the angles, and once you do that, subtract it from 90 and you can get the other ones. So yeah, you can find everything, so that one's good. What about this one? I have, two sides and an angle. Can I do it? And some of you go, yeah. It's a 30, 60, 90. Well, how do you know that? You don't know that. This could be 31 degrees, and that could be 89 degrees. You don't know how many degrees the other two are. So no, you can't do anything right now because it is, you do this in pencil, it is not a right triangle. I think you're getting my game, okay? What about this one? Can I do it? No, it is not a right triangle. Okay? So it doesn't matter. You haven't learned how to do that. All right, let's go to this one. This time they're saying, okay, if I have one side and one angle, or two angles, this one and this one, can I do it? And some of you go, yeah, Ms. Rifkin, we know that this plus this is 90 degrees. So I can just go 90 minus 30. And some of you go, I don't even need to show that. I can just tell it's 60. Well, great. It's a 60, 30, 90. Does that mean I can find the other sides? I sure can. I can do my ratios. Who remembers what's across from my 30? 1. What's my long side? 2, and then 3. The biggest is my square root. So now I go, if this is 2 and this is 18, I can multiply by 9. So that's 18. That means I multiply this by 9. 1 times 9 is 9. Multiply this by 9. 9 times rad 3 is 9 rad 3. So yeah, I can find all the sides and I can find all the angles. What about this one? I have a 45, and there's a 45, 45, 90, and there's a 30, 60, 90. Okay, well, can I find anything else? Oh, actually I could. I could find this angle by going 180 degrees minus 45 plus 30, which is 75. So I know that side is 105. But could I find these two angles? No. So I could find one more angle, but I can't find the sides. And then what about here? If it's moved over here, yes, I could go 180, add these two, dot, 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 so I can find the other angle, but I can't find the other sides. Okay? So let's go to the next one. What they're saying is, all right, this person thinks that more than one triangle exists. Are they correct? Okay, well, yeah, because I could have the exact same triangle, but I can make it bigger, and it'll be obnoxious. And this could still be 45, this could still be 60, and this could still be 75. Do you guys remember, I don't know if you do, last year, the difference between congruency and similarity? Congruency means, okay, this triangle is exactly the same as this one. This side, this side, this side, this side, this side, this side, this angle, this angle, this angle, this angle, this angle, this angle. Everything was the same, and then we proved they were congruent. Similar, and that was like ASA, AAS, SSS, and SAS. And then your teacher went, we can't have that one. And then there was another one that was an AAA. Well, we have proved that those are similar, but they're not exactly the same. This is a smaller version, this is a bigger version. Okay? All right, let's go back here. Doesn't matter if the triangle is a right triangle. What do you guys think? Do you think it matters? Yeah, it does. Because look, when it was a right triangle, I could figure it out no problem. Okay? But when it was not a right triangle, I couldn't figure it out. Okay? Well, obviously we're going to learn how to figure it out. So, let's go to the next page and see what they want you to do now. So now discuss with your team how to change it so the right, you know what, I don't want to do that. Hold on, I'm going to pause and figure out the direction I want to go here. So what they're saying is you can't do it, but they want you to be able to do it. So what they're saying is if you cut this like this, then this is one right triangle, and then that's another right triangle, and then you could use sine, cosine, tan to find this, 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 which is this, 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 okay? And then you could add them together, and you could figure it out. So like, I could take this, and this would be 60, this is 14, I'll just do one, and then I'm okay not doing it, okay? And then that's 30, so what's across from the 30? 1, 2, rad 3, so that means this is times 7, so that means this right here, length right here is 7, and then this is times 7, so this side is 7 rad 3, and then you could come over here, take this 7 rad 3, and if this whole thing is 20, and that is 7, that's 13, and then you could use the Pythagorean theorem to find that length. Okay? Now, you can do all that stuff, but what they're going to say is, okay, there's got to be an easier way. So let's say I wanted to cut this one in half. If I cut this one in half, there's a right triangle. If this is 45, what's this? 45. If this is a right triangle, then this is a right triangle. If this is 30, what's this? 60. And then I can retake this, put it over here, 60. Oops, you can't see that, I'm sorry. 60, 30, 18, right triangle. What's across from the 30? 1. What's alongside 2? Rad 3. So that means the ratio is times 9. So that means this is also times 9. So this part is 9 rad 3. And then this is also times 9. So this is 9. Then you would take this triangle, which I'll move up here. This isn't easy. They're going to give you a cute little formula. Actually, I'll just put it down here. We'll ignore this question and just bring it down here, okay? And we'll take this, redraw it. That's 45, 45, 90. We said this side was 9, okay? Well, if this side is 9, remember the ratio, 1, 1, rad 2. That means this side is also 9, and that means this is 9 rad 2. So if I was to draw the original triangle, that's 18, that's 30, that's 45. 45 plus 60 is 105. This is 9 plus 9 rad 3. And this is 9 rad 2. And now I found all the sides and the angles. And I bet you would agree that's a pain in the tush. There will be a better way in the next section. Okay? So, when you look here, I think they just want to know, can you actually, this is just a repeat of what we did on the first page. Can it be a right triangle? I mean, can you find the angles? If you can, make it happen. If you can't, don't. Okay, this one I think is just multiple choice. I want you to also solve it. Once you get the answer, I want you to solve it. Otherwise, you're just going to circle a letter, move on, and not even read it. Okay? So I need you to solve it also. Dot, dot, dot. This one, just a review of simplifying logs. This one, let me remind you, if this is squared and this is squared, it's going to make a circle. Now, if you're stuck, you don't know what to do, you can always take this, graph it, and put it into Desmos. But I want you to try not to do that. Remember, with a circle, what are the important things? The center and the radius. Okay. This one, they want you to decide what type. Let's see, they want you to find the x-intercepts and the y-intercepts. You could graph it, put it in Desmos, and cheat a little bit, and manipulate yourself in a way to be able to get the answer. But what I would do is I would just simplify this to the best of your ability. And since it's squared, I would factor to get my x's. And to get my y-intercept, I set my x equal to 0, play the same game here. But you might have to move some stuff over because it doesn't say y equals. This one, I don't care. Okay, and that's the lesson.